Yes, hello teachers. Good evening. I hope everyone is well. Welcome to our today's session. That's the second session in physical computing, the one we started yesterday. Today will be a progression of the same. I might sound new, but I've been with you for a number of sessions that we've been here. So my name is Eliud Ochieno. I work at Angaza Elimu under the Buni program. So today I'll be your meeting moderator for today, stepping in for James, who probably will not be able to join us today, but so far everything will be okay. Our today's tutor will be still Mr. Lewis, so he'll be taking us through the physical computing, specifically focusing on robotics as well as Internet of Things Foundation. That's how IoT or Internet of Things finds its application in robotics or either in the other. So feel most welcome. In case you have anything from your end, whenever Mr. Lewis will be presenting his slide, just feel free to raise your hand, or you can as well share your query on the chat. Then probably we'll be able to respond or give you a chance to ask a question if you have, to make the session more interactive. I feel most welcome, and I think Mr. Lewis is already with us. If he's ready, we'll just start it off. But in case you have any question based on what we had yesterday and probably what we'll be having today, you're all invited to feel free and ask whenever it's required.
Hello, Eliud.
Okay.
Probably we can give like 5 minutes so that we
Okay.
can have a good quorum so that we can be able to start after that.
Okay, that's fine.
Okay.
So probably can give it start from 8:30, 8:20. I mean, sorry, 8:10. That will be okay.
Yeah, that will be okay.
Okay, fine. Yes, hello teachers once again. I think it's already time. Probably for those who haven't joined, they'll join us in the process as we proceed. But if okay, I'll just invite Sir Lewis, then he can kind of start us off with the today's session. Lewis, you're there? Feel most
Yes,
welcome.
I am.
Okay.
Thank you so much, Eliud. I hope everyone is safe, regardless of what's going on in the country today. So I hope everyone is safe where they are. So today's session, we are going to cover something on robotics and IoT foundations. So yesterday's session, I'll just do a small recap for yesterday's session. We covered an introduction to what IoT is. We looked at the definition for IoT and how we can be able to use IoT websites such as Tinkercad, and how we can be able to program onto a board such as Arduino. So for today's session, just as I promised, we are going to be able to measure these distances. A good example is the one used in malls, whereby it detects motion and then it's able to open the doors automatically. So we'll do something similar to that, and then from there you can be able to understand how everything comes up together. So today's topic is on robotics and IoT foundations. So we'll start it off on what a robot is. And then a robot is a machine that is capable of performing tasks autonomously or semi-autonomously. So what this means is that a robot can be able to perform any task without a human presence. So there are some robots that, for example, we have the cars in the US called the Teslas. We have the ones in China called the BYD. These are automatic cars that can be able to drive themselves from one point to another. So we can say these are examples of robots. And then we can look at the core components of robots. So we have 5 in general. So in order for someone to build a robot, you need to have these 5 core components. So the first one is controllers. And for this one, we are going to look at different controllers. Yesterday, we looked at the Arduino that we used. We have something called the Raspberry Pi. This one, it's a form of a small computer that can be able to act as a microcontroller. So you can program on it. It acts like a small computer, and then you can be able to do tasks on it. And then we use sensors to detect environments such as cameras. We use ultrasonic, we use light sensors, motion sensors, temperature sensors, and IR sensors. So sensors can be used to look at the outside environment. For example, you have your car which drives by itself. It has LiDAR sensors, or it has camera sensors which look at the outside environment, and then the car can be able to calculate the distance. It can be able to see whether someone is in front of the car so that it can be able to stop by itself. It can also be able to increase speed if the car ahead increases speed or something of the sort. And then we have something called actuators or motors. So in order for you to create a robot that moves, we need to have motors in place. So motors can be able to enable us to create robots that have wheels, or robots that have arms that can be able to move from one degree to another. And then we'll require a power source. So for this one, we'll require battery packs or structural frames that provide energy and support. So for this one, we can use the normal batteries that we have. We could also use solar energy or some other sort of energy. For example, we can use nuclear energy in some robots to just get it as a form of power source. And then we also need to connect to it. So we can connect to robots using Wi-Fi, Bluetooth. We have something called LoRa, long-range communication for IoT devices. So by the end of this session, hopefully you will be able to utilize whatever information you get from here. You can be able to create your own robots using the materials that we have at Tinkercad, or you can be able to purchase these physical items from the knowledge you get from this bootcamp. So we are going to look at the different types of robots. So we have five types of robots. So we have the first one, it's industrial robots, and then it's used to automate manufacturing process with precision and efficiency. So we have examples is articulated arms. So for articulated arms, these are robots that are used, for example, in Chinese manufacturing companies, or for example, the Tesla manufacturing company, or any manufacturing company that you have in mind. Instead of people using their arms, we have robots that can be able to have connections to them. So they can be able to weld, they can be able to for example, fold heavy metal, they can be able to do anything. So these articulated arms are programmed so they can be able to do all that. We also have Cartesian robots that can be able to do to achieve the similar objective. And then for the applications, they're used in assembly lines, whereby we develop like heavy machinery. They're used for welding and also used for painting and material handling. Then we have collaborative robots, in short, cobots. This one are designed to work safely alongside humans without need for safety gauges. So these ones, they can work side by humans, and then they require like they require like less protection for safety cages. And then the applications, small to medium-sized enterprises for tasks like assembly, packaging, and quality inspection. And then in case you have any questions so far, you can just type on the chat, and or probably you can just raise your arm, and then I'll be glad to help. And then we have service robots. So for service robots, they assist humans in an industrial environment. So for these ones, we have examples such as robotic vacuum cleaners, lawnmowers, and concierge bots. So of late, in the past couple of years, there's been new hotels. Mostly I've seen them on TikTok, Chinese hotels, whereby they don't use waiters as their servers. They have robots that come, then it has a screen on it. You can place your order on it, and then it goes to the kitchen, then it comes back with your order. So these robots are called concierge robots, and that's an example of them. So they can be able to do household chores, they can be able to do hospitality service, and they can also be able to do customer assistance. Another example of service robots is the ones that we have today, for example, in WhatsApp. Probably you have a company of yours, and then each and every time you receive emails or text, you can just create an automated service that can be able to use AI and reply to your chats automatically. So that's a service robot in itself. It's called a chatbot. You can look more on that. And then we have medical robots that are used in medical procedures and patient care. So with the development of 5G right now, we have robots that can be able to use 5G. I saw a video not long ago whereby someone was taking the use of 5G, and then the doctors were in China, but then the operation was being done in the US. But then due to the advancements of the speeds of internet, you can be able to get like real time. So when someone uses this robot, whenever they make a move, the robot on the other side of the world also makes a move. This is only possible due to the fact that people are able to access fast internet. And then we have autonomous mobile robots. So these ones include drones and warehouse robots. So it's sad enough to see that in Africa we have all this information, but then we can't use all this information. So most of my examples I'm going to regard to the Chinese, to the Americans, to all this. So it's really important that us as Africans also see how much far behind we are and how much further we can be able to go. So on this, going back to the autonomous robots, in China, they have, you see the way we have Uber Eats. So whenever you order food on Uber, someone comes with a border and then takes the food from wherever you've ordered from, let's say KFC, and then they come with the border or the bike up to your place. So in China, they use delivery drones, whereby in case you've ordered something, a drone has your IP, location details, or your address. It just takes the package, goes in the air, and then it comes directly to your location. So it's really advanced technologies, and then it's something new. For example, I also saw like they have now autonomous air taxis. So for this ones, it's just a drone, and then it can be able to like carry people from one place to another. So like there's a lot of advancement in robotics. This is a really like new concept. Well, not new per se, but then it's something that humans are now like taking advantage of, and there are new robots each and every day to achieve a specific purpose. And then lastly, we have humanoid robots. So for this one, they resemble human form and behavior and can be able to interact with human beings. So these ones, we have Tesla is doing something specific to this. And they said by the year 2030, we'll be having robots such as this walking around in our universe. So we'll be having humanoid robots that you can be able to converse with, similar to the case of we have of ChatGPT. Right now, someone can use ChatGPT to converse. People use them as the therapist. People use ChatGPT to gain ideas. People use ChatGPT for various reasons. So if, for example, we already have the reasoning for ChatGPT, and then if we put it in a robot that can be able to walk, do several tasks, we can be able to achieve this. So there are good examples here. I know of this one called Sophia. It's an artificial intelligence that can be able to make facial expressions. It can be able to speak to someone, hold conversations. It has eyes. It can make facial expressions, express emotions, and all that. So the applications, it can be used for customer service, research, education, and entertainment. So that was the theory bit. So for today's session, we'll also work with Tinkercad. So hopefully you've not forgotten your login details for what we did yesterday. So today we'll be able to work with a sensor that's called an ultrasonic sensor. So an ultrasonic sensor looks something like this. So today we'll have, yesterday we had the Arduino, we had the LED, and we had the resistor working all together. So today we're just going to take the knowledge that we learned yesterday, and then we're going to add one sensor. So this sensor, it's called an ultrasonic sensor, and then its work is it's able to detect distances. So we are going to look more on this. So let me just share the website for Tinkercad. Let me just share the link for Tinkercad, then we can proceed. So let me just open Tinkercad circuits. So you can also open this website, Tinkercad circuits. So let me share this link so that you can also be able to follow along with me. So I've shared it on the link. Okay, so far I see there are no questions. So I've shared this link here, Tinkercad circuits. And then what we did yesterday, once you come to this website, we need to click on the profile page, come here to new design, and then click on circuits. So you need to click on the profile page, come to new design, and then click on circuits. So I'm going to do that. Hopefully you're also following along. So once I create a new circuit, it's going to open now this page here. And then once it does that, I'm just going to drag and drop everything that I need. So for today, I'm going to need an Arduino. I'm going to drag and drop an Arduino there. I'm also going to need a small breadboard. Remember the breadboard, we talked about it yesterday, and we said it has vertical rows and columns. But then we're going to cover this today also, so that we can also finalize on that. And then we are going to drag an ultrasonic sensor. So let's put it here. There it is. And then we're also going to drag an LED. There it is. And also lastly, we're going to drag a resistor. So today we're working with 5 components. So if you missed yesterday's session, we were able to turn on this light on and off for a couple of seconds. So for today's session, we want to be able to measure distance using this sensor here. It's called an ultrasonic sensor. So we want to be able to measure distance. Okay, so I want to move it here. Hey. Okay, so we want to be able to measure distance so that we can be able to like get distance from one place to another. So for my ultrasonic sensor, let me just check. Distance. Okay. So I see for the ultrasonic sensor, there's one with 3 clips and then there's one with 4 clips. So make sure you've dragged and dropped the one with 4 clips. So here for search, you just search ultrasonic distance sensor. So make sure that it has 4 channels. So it has the ground, it has something called echo, it has something called trigger, and it has something called VCC or power. So that's what we'll be working with. You can just search here ultrasonic distance sensor, and then we can proceed from there. Okay, so let me touch on these items once again so that you can be able to like remember what we discussed on yesterday. So this one here, it's called an Arduino. It's a microcontroller, or just someone can say it's like the brain of the whole operation. So we have it here. So let me put it in a vertical standing. So it has several pins that you can be able to like use these pins. So let's say you wanted to control something. You can control something using this pin too. So these pins, you can choose them from the board. So you can say, I want to make use of pin 13. You can just control pin 13 from there. I want to use pin 12. You can just control it from there. I want to use pin D11, control it from there. Similar case to these pins here. So these ones, they're called analog pins. But then most sensors normally have this digital pin. So we'll just be working with these digital pins for the moment we have. So nextly, we'll focus on the breadboard. So the breadboard looks something of the sort. So we have these horizontal lines. So for example, if I have a battery that's 5 volts, if I put 5 volts here, the whole line is going to be 5 volts. So this is the negative bit, and then this is the positive bit. So if I put like a negative here, it's going to be all the way through this horizontal line. Similar case to this positive line. And then now we have here these vertical lines, A to E, and then F to J. So if I put something here, A to E, it's going to represent this whole line here. So these 5 holes, if I put, for example, a 5 volt here, it's also going to occur here, here, and lastly here. Similar case to all this. So this is something that you should remember when working with a breadboard. And then the LED, we looked at it yesterday. So the LED has 2 terminals. The negative terminal, which is the cathode, this small one that has no fold to it. Then we have the positive terminal, which is the anode. So this one, there's nothing much to it. Similar case to this resistor. So we have, whenever we are working with this type of LED, we have to put this resistor, because without it, the LED is going to burn out. So the resistor is supposed to reduce the amount of current coming to this LED. And then lastly, we have now this ultrasonic sensor. So this is the first time, probably if you're working with IoT, this will be your first time. So for the ultrasonic sensor, we have 2 holes here, 2 major holes. Well, not holes per se, but then for this case, we'll call them these yellow circles over here. So we have this first one and the second one. So we have down here something called trig and echo. So how this works, let me see if I can find like a tool to draw a white. I don't know if like they removed like the tools to draw. Okay, so I'm not familiar with these tools. Okay, so let's say Okay. So let me see if I can draw something. Okay, how to draw? Okay, so we can use this. Oh, probably instead of that, I can just use paint. So that I can show you how this thing works. So we have an ultrasonic sensor. Here it is. We have the trig pin at the trig circle. You see here it has a T and here it has an R. So we have this, it's called a trig pin, and this one is called an echo. So let's go to the paint. Then let me draw how it's supposed to be. So we have it here. So it looks something of the sort. This, and then it has the trig circle and also the echo circle. Okay. So if we are to look at it from this direction, let's say we've put it now in like one direction here. So you see, the work of the echo pin is to produce an echo that can go whatever direction. So this echo goes in that similar direction. And then, for example, let's say it hits a wall. So this is a wall here. So for example, if it hits a wall, this echo is going to come back here. So this is the echo. So I'm going to write here echo. And this is the other one is the trig. Trig, just like this trig. So if I send something, it's supposed to like send a frequency to this wall, and then we are going to receive that frequency back. So let me just get rid of all these so that I can explain it again. So let's say we have a wall. So this is the sensor here. So this is our sensor here. And then we have a wall. So let's just draw this wall here. So the work of this, and this line is fairly straight. So I don't know if it's used AI. Well, it's fairly straight because I'm using a mouse. So this one uses echo pin. So it releases an echo. The echo goes straight to the wall like that. And then once it hits the wall, it's supposed to come back and relay the same information to this sensor now. So this one, it works with two frequencies. So it sends waves and then it also receives waves. So the echo pin, this one here, it sends waves, and then this one, it receives the waves. Oh, I thought there was someone with a question. Okay, so let me just go back to this. So it sends the waves and then it receives the waves. Okay, so upon doing that, since this is frequencies, we can be able to measure how the distance of frequency. So let's say this one here, it took 2 seconds. 2 seconds. And then the frequency that we are sending, let's say it's 9 megahertz, although this is just an example, 9 MHz. This is just an example, for example. So if we know we are sending this and then it takes 2 seconds, we can be able to calculate the distance of this, because we know, for example, 9 megahertz goes for 2 seconds. How about 1? So we can be able to like accurately like get distance in centimeters. So we are going to look at that. So hopefully you've understood that. So let me come back here to the design so that we can be able to connect now all the dots. Okay. So let me just switch this back. And then now we can be able now to connect everything together. Okay, let me just delete this line. Stubborn. Okay. Okay. So the first thing that we're going to connect this LED. So we're going to place it there. So let me just zoom in. We've connected the LED there. And then the next thing we need is this resistor. We're just going to come here, put the resistor here, just like that, like that. And then now we can be able to now connect now this this pin. So we'll place it somewhere like let's put it just somewhere like here, like that. Okay, so we have our setup there. So you just drag and drop to make sure that it's connected to power, not power, but then it's connected to 4 pins on the horizontal lines, like that. And then we can now make several connections. So for today, yesterday we used 3 volts. For today, we are going to use 5 volts. So instead of, so let me just put this to be horizontal. So instead of us like getting 5 volts from one hole, what we can do, we can just put 5 volts here, down here. So we can come here and say, we want to take this, let it bring it down here, bring it down here, and then we can also now bring it here. And then I'm going to change the color of that line to red, just like that. So this is 5 volts. It comes down here, and then it comes to here, the positive side. So all this line, it's going to be positive. The whole of this line is going to be positive, just like that. And then the next thing, we want a ground. So for ground, here it is, the ground line. Bring it here. I want it to make a line there. Bring it there, and then bring it here. So that's the ground. So we're going to put it as black. So we have the positive terminal, which is 5 volts, and then we have the negative terminal, which is GND, which is now GND. So it's come here like that. So yesterday we were working with the GND. So remember, this is the negative side. So if we want to connect this to the power that we have, we don't have to connect all these lines to the Arduino. We can just connect this here. Remember, this whole line is goes to the cathode. We can just bring it here. We can just say we want to bring this here. So this means that this one, it's going to take power from this whole line. So it's going to take from this hole, and it's going to bring it here to this negative bit. And then for the positive end, for this terminal here, we just need to connect it now to a pin. So we can just bring it somewhere like, want to connect it to pin, let's say we want to connect to pin 2 or pin 3. So pin 3 like that. I hope you're able to follow along. So this is like we'll name it, we'll put it as yellow. So this one is going to give information now to this LED. So whenever, for example, we detect a distance, we can be able to like get that distance and then relay that information to the LED. So the work of this pin 3 will be able to do that. Okay. So the next thing I want us to do, I want us to connect now the VCC. So VCC is power. So come here, VCC, and then connect it to the positive terminal. So this is power. So we'll put it as red so that we can have like a key. And then for the ground, we'll do the same thing for the ground. Here it is, and then put it here to the ground. So we'll put it as black. So right now, we've not gone like really far. We've just connected all these to positive and negative. So we've connected this to the negative terminal. We've connected this to the positive terminal, and this to the negative terminal. So that's all we've done at the moment. Okay. So the next thing I want us now to do, we can be able to take now this trigger pin, the trigger pin, and then I want us to bring it. So I don't know how I'll take it. Okay, so I can just take it from here. Okay, I can take it from here. I can bring it down here. I can bring it down here. I can come, and then I can say I want it to be on pin 12. So bring it here like that. So this one is going to connect now the trig pin. The trig pin is going to be connected to pin 12. So we can put that line as, we can put it as green, like that, trig pin. So trig pin comes here, and then it's connected to pin 12. Then for the echo pin, I'm going to connect the echo pin. So I'm going to take that down here, just like that. And I'm going to connect it to pin 13, or probably let me just connect it to pin 11 or 10, either of the two. So I'm going to put the color in. I want it to be, we can go with purple so that we can have like a clear definition. Okay, so by doing this, we have achieved all the wiring that we require. Okay, so you're too fast. I can't keep up. Oh, sorry about that. Okay, so let me repeat once more. Okay, so we have the LED, we have the ultrasonic sensor. Okay, so the first thing we're going to do, we are going to come here to the Arduino board, and then we're going to take 5 volts like this, bring it here, and then connect it to this line so that we can be able to access 5 volts from this whole row. So by doing that, this whole horizontal line here, this row, it's going to be 5 volts. Okay. So the next thing, we are going to come and connect the ground, which is GND here, and then bring it here GND, and then we bring it here to this negative row so that we can be able to access ground. Because by doing this, it eliminates all the lines. For example, if I wanted to like take ground, you see I've taken ground from here. And then I'm sorry if like the wires seem to like be overlapping. But then remember that if I connect it here, it's just going to ground. When the wires come over it, it doesn't mean that it's connected. It needs to, hata ikikuja juu, it doesn't mean that it's connected. It means that it's just overlapping the wire. There was no like part for me to like go without like overlapping all these wires. They had to meet at one point or another. So sorry if it's overlapping. But then if, for example, I want to connect this to pin 12, now the pin 12 one is the trig pin. So I just come here, click on trigger, well, the trig pin, and then follow this path to here now, pin 12. If I want to connect this to pin 11, which is the echo pin, I come here, follow this path to the echo, and then I connect it here. So even if they are overlapping, you can see here, if I put this, it seems like they are overlapping, but then that does not, that does not make the connection poor. It just means that the wire is going over now this line. So you can see here, we have a black line here, going here, but then the other two ones, the other two lines are going just over it. So I hope you've understood. I don't want anyone to get left behind. Okay, so what is the role of the trigger pin? Okay, so what is the role of the trigger pin? Okay, so remember this drawing here. So we can name this. So let me just get rid of everything here. Okay, so let me just draw it once more. So the role of the echo pin is to send echoes from one point to another. Let me see if I can increase the pixel for this. Okay. So the role of the echo pin is to send signals from one point to another. So it sends signals. So let's say this is a wall. This here, it's a wall. So the role of the echo pin is to send frequencies from one place to another. And then these frequencies, most of the time, or all of the time, they normally bounce back. It's like an echo, it's like sound. If you put sound, for example, in an empty room, then it goes and hits the wall, it bounces back. So it applies the same concept. It sends the frequencies, and then the frequencies bounce back. So the work of the trig pin is to collect now those bounced back sounds. So this one sends information, and then this one receives information. Okay. So once you send information and receive information, you can be able to calculate how long this information has taken to reach to you, so that you can be able to like calculate like the distance. So, but then we look at all that calculation in just a short while. So basically that's how. So it sends information and then the other one receives information. Basically it's just bilingual or dual directional. So sends information, receives information. It works on that, like that. I'm too fast. Oh, sorry. Okay, so Zacton, or probably where should I go back? Because it's really, well, it's a really interesting topic. Okay, so the presenter screen is not showing on my side. So could you kindly confirm? Because on my end, I'm sharing my screen. Are you also experiencing the same on your end?
Lewis.
Yes.
I think it's could be a network issue from his end, because for me I'm seeing and I can able to see your screen.
Okay.
If he's not able to see your screen, probably he can just drop, then rejoin afresh. Probably that could solve an issue.
Okay. Thank you so much, Eliud. Okay. So I hope by now you've understood. In case of any question, just feel free to ask. I encourage like questions so that it doesn't end up being a boring session. So all the questions I'll appreciate. So remember, this one, the echo pin, which is normally on the right side, it sends information, and then this one receives information. But then the information is in frequencies, so we can be able to calculate distance using that. Okay, so that's the connection that should. That's how the connection should be. Oops. That's how the connection should be, as you can see from this diagram. So this diagram is a bit different, but then I've at least tried to get all the concepts. So the next thing we want to look at now is how we can be able to write the code that is going to make all this work. So we have an ultrasonic sensor, we have an LED. We want it such that whenever we come to a certain distance, so let's say we want to come, for example, 100 meters, the LED turns on. So we'll be able to achieve that. So we just need to come and click here on code, like that. So once you've clicked on code, we need to come here on blocks and then click text. So I'm going to repeat again. So as we did yesterday, we come here on code, and then we're going to click on this and then click on text so that we can be able to like get text. But then for today, we are not going to use this code here. We're going to delete that code. And then let me copy this code here, and then I'll also copy it on the chat so that you can be able to do it. So this is what we are working with. So let me change some few things here. So let me look at the trig pin. This one, the green one, it's going to pin 12. And then the other one is going to pin 11. And then the LED is going to pin 3. So let me change those few things, and then I can be able to now explain this code. So also let me share this code with you so that you can be able to also like follow along. So I'm going to, oh, Eliud, could you kindly share the sign-in form? Okay, so let me share the code with you. Okay, so let me just share this. So since you can see here on the chart, whenever I write the long code, it's not coming as it's not coming as a whole. So let me share this website here. It's called CodeShare. So if you click on this website, it will bring you here to this page, and then you can just copy this code from line 1 all the way to line 39. So I'm going to repeat again. Since we're having an issue of sharing the code, I've just shared it on the chat, and then it's not come as the whole code. So since I want you to have the whole code, I have come to this website. It's called CodeShare here. And then I have copied this code here. So you can be able to like come here, select the whole code, and then copy it so that you can be able to follow along. So I hope you've understood. So here's the link. I've also copied the link here. So the link is here. So just click on this link so that you can get this code. So yeah, I can see someone here is copying. So there's someone who is copying if it's this color purple. So just click on Control C, or just right click and copy, and then we can be able to proceed. So here's the link. Okay, so I can see someone has said done. Okay, so we can just proceed. So we have the code here. So let me try and move this to this side. So the first thing, we want to initialize the trigger pin. Here it is. So the trigger pin here, we want to initialize this pin, and then this pin comes to pin 12. So we're going to say this pin here, so we can assume this. So we're going to say this pin, it comes to pin 12, this trigger pin, it's connected to the Arduino to pin 12. As you can see, the green wire comes here to pin 12. And then the echo pin, it's connected to pin 11. And then here's the echo pin connected to pin 11. There it is. And then for the LED, it's connected to pin 3. So for pin 3, we have it here. So you can see here, the yellow line, it comes here to the resistor, and then the resistor is connected to terminal 1. So it's connected to pin 3, like that. Then at the moment, we'll first assume this, and then we'll come back and put all this together after I explain this code. Okay. So here, we have something, or probably let me just start simulation so that you can see what our aim is to achieve. Okay. Okay, so let me just click here. Then let me just zoom in a little bit. Okay. So we want it such that if this thing, if this green ball is below, it's below 50 inches. So 50 inches is here. If it's below 50 inches, I want the LED to turn red. But then if it's above, I want the LED to turn off automatically. Okay. So this is what we plan to achieve today. So here, this green ball, we can be able to use it. So you can see here, this green ball, it symbolizes how this ultrasonic works. So this one sensor reading the frequency, and then it bounces back and it's received here on the trigger pin. So for example, if someone is comes and intrudes into your house, or someone comes close to your gate can turn on the lights automatically using this concept. If someone is far away, the lights turn off automatically. Okay, so this is what we aim to achieve. Okay, so let's look at the code. So for the code, we'll come here to void setup, and then we have something here called serial begin. So at the moment, this serial begin, basically, it's how fast information is sent from the sensors to the Arduino board. So that's why we have this number here. So this is the speed at which we send information back and forth. So for this one, it's supposed to be 9600 times millisecond. So it's how fast we send information from the sensors to the Arduino board. Then we have pin mode. Here we have the trigger pin, which is this trigger pin here. It's an output. And then we have the echo pin. It's an input. Okay, so it sends and then it receives information. So this is what it means: output and then input. And then we also have an pin mode, which is LED. It is an output here. The LED is an output. Okay, so I hope you've understood that. And then here on the loop, yesterday I said this loop, it enables code to repeat forever. So you can be able to repeat code over and over and over again. Okay, so we've put our main code here. So we have digital write, trigger, low, and high. Okay, so this code is a bit mixed up because it says trigger is the one that gives low and high, low and high, low and high, but then I'll try to explain it as easy as possible. Okay, so it's a bit confused. So for this one, the trigger is the one that sends information, and then the echo pin is the one that receives information. So this one, the trigger, if it says high, it's supposed to send information to the wall, and then this one's supposed to receive, it sends information, it's turned off here. So I can say here, if you see low, I'm going to write here, it's turned off, and then here it turns on, and then it's turned off again. So let me copy this and put it here. So it's turned off again. Okay, and then the duration here, well, this is more into math, so I won't go into this. But then basically, all frequencies have a rate at which they travel at. For example, if you have a distance of Nakuru to Nairobi, it's 150 kilometers, regardless of how fast you get there. For example, if you're traveling by car that's going 80 kilometers per hour, it will take 2 hours roughly. So frequencies also have the same. So we can be able to measure distance using frequencies. So I won't get much into this math because it will be a little bit confusing. So allow me just to skip this bit. But then basically from that, just know like frequencies have a rate at which they travel at. So for example, if I have a frequency of 9 megahertz, it travels at around 150 kilometers per second. So whenever it takes like 2 seconds, we're going to know that it's traveled like 300 kilometers. So basically this is what that math explains. But then I want to get into this math because there's a lot of calculations that's going into here. And then here we have a loop that says if the distance, so if inches, so let me click here.
Hello, Lewis.
Yes, yes.
Thanks, mate. Sorry for interruption. Just to add on something there, like the trig uses that sound frequency. So we are operating with sound, which is around 345, the one they are seeing in your code. Yeah. So it's more for sound, speed of sound. That is what we are using the frequency.
Oh, okay. Thank you so much, Eliud. Okay. So basically this code is a little bit complicated. So I'm trying to explain this code in the easiest of ways possible. So that's why like I don't want to go into like the math of it. But then basically here we have a loop that's saying if the number of inches is less than 50, so if it's less than 50, you can see here we have inches, which is 46. 46 is less than 50. You want the LED to go high. So the LED will turn on, just like that. Else, if it's greater than this number, 50 inches, we want the LED to go off. So that's why the LED is going off. Okay. And then lastly, we have if inch is less than 100, we can be able to print these inches. Okay. So we have here a serial monitor. Okay, so the serial monitor, it's like basically a place whereby we can print things, the outputs. So if an inch is less than 100, so if it's less than 100, for example, it's right now we are at 76, it's coming to print here 75 and 192 inches. So we can be able to like print this distance from there. So I believe you can see whenever like I change this, it's supposed to change to 69 inches to 97 inches and all that. So that's the basic bit of it. So we can be able to print all that to the serial monitor. And then, yeah, basically that's it. So if we now bring this less than 50 inches, somewhere around here, somewhere less than this, the LED is going to go on. If we put it more than 50 inches, the LED is going to go off. So I hope you've understood this concept. Basically, this will need more training. So after this, I'm going to send the recording. So Eliud, kindly confirm if you've gotten the recording. But then I'm going to send the notes shortly after this, and then you can be able to follow along. Okay, so I'm going to ask if anyone has any question, and if you've understood. Well, it was like a really complicated session, but then I had to like make it so simple so that to see float.
How do I save my projects?
Or how do you save your project? Okay, so you see, the project is auto-saved. So so whenever you just so all changes are saved automatically. You can see here all changes are saved automatically. So if you want to access your projects, so let me see if I can just come here to Tinkercad. Okay. So if you want to access all your projects, you just need to come here to Profile, My Designs. So click on Profile, My Designs, like that. And then you need to come here to your design. So you'll be brought here to your designs. There's a 3D model, there's circuits and code blocks. So you just click on circuits, and then you can be able to see all the designs that you've made. So for my case, I have this. It was made a minute ago, or the last time it was modified, it was a minute ago. And then we have this one, another one, an hour ago, a day ago, for yesterday. You can be able to see all the progress that you have. So that's how you can be able to see your code.
Thank you.
So is the ultrasonic affected by temperature? Okay, so ultrasonic, well, mostly it's frequencies. So probably let me just ask, let me just Google that. Is it affected by temperature? Well, I'm not sure. Let me just ask ChatGPT. Yes, it says yes. Why? So it works by emitting sound waves and measuring how long it takes. Yeah, it says that it's affected by temperature. So you can Google more on that, Mr. Simon. But then I'll share this with the group, also these findings.
Yes, Lewis, maybe just to add on something on that response. Ultrasonic is an electronic component, and when you look at any electronic component, there's an effect of temperature because we call them active components. Active components are like capacitors and resistors. When the temperature rises, it affects the operation of that particular component that supports the sensor. So possibly that could be the cause, but in actual operation, it doesn't. Like for instance, sending out a signal, as long as the sensor is operating within the normal temperatures of operation, let me say room temperature, it can't affect.
Okay, thank you so much, Eliud. You're welcome, Nahori. Okay, so unless there's any other question, I'd like to call it a night.
Maybe just to add something, in case someone hasn't presented their registration, please do so but I think for all of us who have managed to attend, I can see you managed to register down your put down your registration. Just in case either of you, feel free to do so before you leave.
Okay.
Otherwise,
So
thank you so much, Lewis, as well as the teachers. And let's stay tuned in our groups.
For a group
There'll be
link.
more information to be shared.
Hello, Eliud. Eliud.
Yes, yes, Lewis.
Oh, there's someone
Yes.
asking for the group link for the WhatsApp. You can just kindly share. Okay, so Eliud will share the group link. Does programming of robotics is affected by nature of surface? Does programming of robotics is affected by nature of surface? Now, by nature of surface, do you mean like the terrain? If it's the terrain, yes, it affects if it's the terrain. But then by surface, probably you can elaborate more. Oh, sorry, Miss Brenda. So you had requested CSS slides. Okay. So let me tell my colleagues to share it on the group. Yes, I'll tell them to share. Okay, so that's it from my end. Hope you have a good evening. See you next week.